Okay, welcome to today's tutorial. In this video, we're going to look at the speed of a transverse wave. Speed of a transverse wave, and we'll focus on the speed of wave on a string. We're looking at the wave on a string, which is an example of a transverse wave. So the formula that we use is v, which is the velocity or speed, is equal to the square root of t divided by mu, where your t is the tension on the string and your u is what? Your linear mass density, right? V is now your speed. So this is the formula that we use, right? Your V is the speed, T is the tension on the string, and U is the linear mass density. So let's look at an example here. A string of mass 10 grams and length 2 meters is stretched by a hanging mass of 2.5 kg. Find the speed of the transverse wave on a string given that g is equal to 10 meters per second squared, right? So the first thing I would want to do here is to fish out the parameters that were given in this question. A string of mass 10 gram. So that tells us that the mass of the string is what? 10 grams. And remember that gram is not the SI unit of mass. The SI unit of mass is kg. So we have to convert to what? Kg. So how do we do this conversion? So knowing fully well that 1000 grams is equal to 1 kg, 10 gram will be equal to 10 divided by what? 1000. So this 0 will cancel out. The 0. 1 divided by 100 will give me 0.01 kg. So this is my mass. So my 10 gram is equal to 0.01 kg. So a string of mass 10 gram and length 2 meters. So the length is equal to what? 2 meters. Is stretched by a hanging mass of 2.5 kg. So it is stretched by a mass of what? 2.5 kg. So the stretching mass, let me put it as ms. The stretching mass is equal to what? 2.5 kg. Find the speed of the transverse wave on the spring, given that g is equal to what? 10 meters per second squared. So what we're looking for is the speed on the transverse wave. We know fully well that the formula for the speed of transverse wave is v is equal to the square root of t over what? U, right? So our v will be equal to, so what is the tension on the string? So let's say that this is the string. This is the string, right? This is a string. And this string is stretched by mass. If you read the question very well, it is stretched by a hanging mass of what? 2.5 grams. So there is a stretching mass here, 2.5 kg, that is stretching, that is dragging it downward, right? So what is the tension on this string? The tension on this string will be equal to the mass, the weight of this object here. So weight, which is force, will be equal to what? Mass times what? Acceleration due to gravity, right? So that will be equal to 2.5 times 10. The mass is 2.5, right? Times 10. That will give us 2.5 times 10 will give me 25 Newton. So the tension on the string is what? 25 Newton. That is the force that is dragging this string down. So that will be equal to the square root of 25. So my tension T is equal to what? 25 Newton, right? Square root of 25 divided by, what is this U? The linear mass density, right? Linear mass density. And what is the formula for linear mass density? This is the linear mass density, right? Density is equal to what? Mass all over volume. But here we're looking at linear mass density. So linear mass density is equal to the mass divided by what? The length of that material. That will give us the linear mass density of a string, right? So the mass of the string, a string of mass 10 gram. So The mass of the string is 0.01 kg, right? And the length 2 meters. So the mass and the length are already given to us. We have them there. So linear mass density will be equal to the mass divided by what? The length, L. So that will be equal to, the mass is 0.01 divided by what? By the length, which is 2. So 0.01 divided by 2, what would that give us? 0.01 divided by 2, that will give us 5 times 10 raised to the power minus 3. And that is 5 times 10 raised to the power minus 3. That is the same thing as 0.00, which is representing this 3, 5, right? So that will be 0.005, right? So 25 divided by 0.005, what would that give us? 25 divided by 0.005, that will give us 5,000. So that will be equal to the square root of 5,000. So the square root of 5,000, what will that give us? Square root of 5,000 will be equal to 70.71. Will be equal to 70.71 meters per second. So this is the speed of the transverse wave on the string, right? Very simple and straightforward. So let us look at the last question that we'll be looking at here. A guitar string has a mass of 0.5 gram and vibrating length 0.65 meters. It is tightened so that the tension on the string is 80 Newton. Find the speed of the transverse wave. So the first thing I would want to do is to fish out the parameters. So a guitar string has a mass of 0.5 gram. So the mass on the string is what? 0.5 gram. And I will have to convert that to what? Kg, because this is not the unit for mass. So to convert to kg, I will have to divide by 1000. So this will be 0.5 divided by 1000, right? So 0.5 divided by 1000, 0.5 divided by 1000, that will be equal to 0.0005, right? 1, 2, 3, 4. 0.005, which is still the same thing as kg, which is still the same thing as 5 times 10 raised to the power minus what? 4 kg, right? So, and vibrating length of 0.65 meters. So the length of the string, of the guitar string, is 0.65 meters. It is tightened so that the tension in the string is 80 Newton. So the tension in the string is what? 80 Newton. Find the speed of the transverse wave. So the speed of transverse wave, V, is equal to what? The square root of T divided by what? The linear mass density. So this will be equal to, our tension is 80 divided by the linear mass density. So our linear mass density is equal to mass over what? Length. So the mass of this guitar string is what? 0.0005 kg. So that will be 0.0005 kg divided by 0.65, right? So if we divide that, 0.0005 divided by 0.65, that will be equal to 0.00769, right? So that will be equal to 0.000769. That's what we had, right? 0.00769, right? Okay. So since that's what we got, so our linear mass density will be 0.000769, right? and this is kg per meters, right? So this will now be equal to 80 divided by 0.000769. 80 divided by 0.000769, that will be equal to 104,031. 104,000 and what? 31. So we'll look for the square root of this. So the square root of this number, square root of 104,031, that will be equal to 322.5. So this will be 322.5 meters per what? Seconds. This is our answer to this question. Very simple and straightforward, right? So these are the major things that you need to know about the speed of a transverse wave. In the next video, we'll look at overtone and the relationship between harmonic frequency and overtone.